Hello my children. Today we're going to be looking at angles. Now some of the stuff you may already know, but if you don't, it's good to know, and if you do know, it's a good refresher. So the first thing we're going to start talking about is parallel lines. Now they are parallel lines. I just want to see if I can use the pointer. Parallel lines are lines there and there. Can you see? They basically will never meet. They're exactly the same distance apart from each other, going in the same direction. So what the notes say is parallel lines are always the same distance apart, like the lines of a page of lined paper. The symbol, so that symbol with those two lines means it's parallel to. For example, AB, so AB, can you see the line AB is parallel to CD. Means the line AB is parallel to CD, and that going from A to B is the same direction as going from C to D. If more than one set of parallel lines appears, we show it differently. So you can see there's a parallel line and they are all parallel to one another. Can you see they've all got the same little arrow on them? And then that one and that one are parallel to one another, so they've got two of them on, so it shows that they linked. Alright, let's move up. Now if we talk about a transversal is a line that crosses or transverses the parallel lines. So here are your parallel lines, and it goes right across. That's called your transversal. So if they talk about a transversal, you know what it means. It says when parallel lines are crossed by a transversal, the pairs of angles on parallel lines described below have special properties, and that's what we're going to be looking at next. So, I think I must go to my next. Okay. So, first thing, I want you to write these details down, please, because there's three different lots of angles that you need to know. So, if we say corresponding, okay, corresponding to me, so that you can try and make an association, means when you're writing letters to each other. So, I write a letter to you, you write a letter to me. So, we're doing the same thing to each other. They're either both above or both below the parallel lines, and on the same side as the transversal. So, you see there's a dot here, and you see there's a dot here. They are both on the same side of the transversal. They're on the right-hand side. And can you see they're both below their line? Below their line. So they're exactly the same, and therefore, they will have, their angles will be identical. So they're corresponding. It means all you could think of, there's two R's there. They're almost related to each other. They both do. So if your angle, let me just draw one, was over here, right, that's above the line and to the left of the transversal. On the other one, above the line and the left, try and see if you can pick where it'll go. We'll go there, okay, and they always do that with the angle. So that will give you exactly the same angles. They say that corresponding angles and parallel lines are congruent. Now, congruent means they are equal, okay? So, corresponding angles are equal. Now, and can you see it's almost in the shape of an F, parallel, with it going down like that. Okay, so that's corresponding. Right, let's move to the next one. The next one is alternate angles. Now, alternate means you're different. Alternate angles are between parallel lines. So remember, the other one could be above or could be below. These ones are between, on opposite sides of the transversal. So, they're in between there, so they're alternate, and they are on this is on the right side, this is on the left side of the transversal. There is one other pair of alternate angles in this diagram. Could you think of them? Right. So, over here is one, and over here is another one. So that would be a pair. And over here you can see how they make the Z. So they're saying they're congruent. These are also equal. Okay? They are equal. Congruent is a good word, and if you see it used, you're going to know what it means, congruent. Alright, let's move up a little bit. This is the last one that I want you to write down and learn. So, co-interior angles. So together, interior, they're on the inside. Co meaning the same, are also between the two parallel lines, but together on the same side of the transversal. So they are tucked away together reading a book. Okay, so they are co-interior. They're inside and they are together, co-interior. There is one other pair of co-interior angles in this diagram, okay? Now, the other pair of co-interior angles would be over there and over there, okay? So it would make the shape like that. One thing you've got to remember with co-interior angles is they equal 180 degrees. So if this one was 80, this one would be 100. So if they give you one, you would be able to work out the other one. Please make sure that you write this down. So just pause the video every time you need to. All right, let's go to our next page. Okay, angles in a triangle. There are three basic types of triangles. You've got equilateral triangles, which tells you what it is. All the same sides are the same length. Isosceles triangles. So equilateral, there it is, exactly the same all the way. Isosceles, they have got two sides that are the same. Okay, so that one would be that one, and that one would be that one and that one. That's an isosceles. And a scalene, they're all different. All different. So those are the three types of angles. I think it's a good idea to write that down as well. Isosceles and scalene triangles may be acute, angled if all angles are acute, right angled or obtuse angles, but equilateral triangles are just one basic shape. So equilateral is over here. Okay, its little man over here says markings on the sides of the shapes can be used to indicate that side lengths are the same or to emphasize that they're different. So this, all the same signs here mean all the same measurements. Those two are the same measurements. Those two are the same measurements. But this one has got one, that one's got two, and that one's got three. They're all different. Okay, let's move up. Next. All right, this is the, now I have printed a copy of this, so I want you to come to me and ask me for it, please. Cut it out and stick it in your book. This is just a summary of what we've done, so let's go through it together. So over here, you've got adjacent angles. Adjacent angles means they're right next to one another. So you can see in this little pocket, there'll be an angle, and in that pocket, there'll be an angle. They're right next to each other. They form a right angle that are complementary, which means it adds up to 90 degrees. If something is complementary, it adds up to 90. Over here, you've got a straight line. A straight line is always 180 degrees. So if we slash it in half and we put this one as 80 degrees, you know that that side is going to be 100. So a straight line is always 180 degrees. If it does a full revolution, it's 360 degrees. Vertically opposite angles are congruent, which means they're equal. So if they're vertically exactly opposite each other, they are the same. In triangles, the sum of the angles in a triangle are 180 degrees. Isosceles, the opposite angles, the angles opposite the equal sides are equal. Okay, an equilateral triangle has all angles are 60, because 60 plus 60 plus 60 gives you 180. The exterior of an angle is equal to the sum of the interior opposite angles. So the exterior, this exterior of a triangle, is equal to the sum of the interior opposite. So I'm thinking it wouldn't be that one, it would be that one, that angle there. When a set of parallel lines is cut by a transversal, you get corresponding, you get alternate, and you got co-interior, and you've already made notes on that one. All right, with all that information, I want you to go ahead and begin the exercise.